All right, so here I've got a polynomial. Looks a little different from the ones we were doing before because it has this x squared, or x to the fourth, I should say, and x squared is here, whereas before we were dealing with an x squared and an x. And also, when we had some higher powers, sometimes we could take out a common factor, like if they all had a bunch of extra x's. But this time, there is no extra x here. So there is also no common factor. Instead, what we do is we're going to factor it normally, where I just break this down. Like, so what multiplies to 6 and adds to 7? Well, 6 and 1, right? Multiplies to 6 and adds to 7. So I can, again, make my factors same way. But now, if I were to multiply this out, I'll get x times x gets me x squared, right? Like a normal quadratic. But I don't want x squared this time. I want to get what I started with when I multiply it out. So x times x gets me x squared, but I want x to the fourth, right? Well, how do I get x to the fourth? Well, I am basically going to split this up in half, right? And this trick only works if the big exponent is exactly double the middle exponent. So if I break up my 4 in half, I get 2 and 2. And yeah, 2 matches up with this. So it will work. So that means I am changing each of these exponents to x squared. That way, now when I multiply x squared times x squared, I get my x to the fourth. And even when I multiply a number times x squared, they will combine into this middle term. All right, so this would be final answer. All right, here's another example of factoring with big exponents. Again, notice that two things. First, that while the exponents are big, this one still does not have an exponent, so I can't just factor out a common factor because this one doesn't have one to give. Second, my big exponent, again, is exactly double my middle exponent. That's an important thing, right? Because this trick only works if it follows that pattern where the big exponent is double my middle exponent. So if it does, then I can continue. So again, just factors of c that multiply here and add to b. It's going to be 6 and 8 this time, I know. And since I want negative 48, I know one of them will be negative. And which one's going to be negative? Well, since my b is negative, that means my big one will be negative. So now positive 6 minus 8 gives me negative 2. That fits. So now I've got x plus 6, x minus 8. Right? And again, now if I multiply back, I would get x squared. I don't want x squared. I want x to the 8th. So in order to get x to the 8th, I split this 8 in half. So 4 and 4, right? And again, these 4s should match up exactly with my middle term. And I just basically just tack them on. So I get x to the 4th plus 6 and x to the 4th minus 8. And that's it. All right, so here we are factoring a polynomial, but this polynomial has way different exponents than we're used to. We're usually used to x squared and x. This one has, we're usually used to an x squared and an x, but this one has in x to the 10 and x to the 5th. And we can't even factor it a common factor because this one does not have an x. All right, so what do we do? Well, part of the pattern comes with this x squared and x, where you can see x squared is really double of this exponent, and that does follow in this, where double 5 gets me to 10. That's actually a pretty important part. All right, all of our problems are going to follow that pattern, where the big exponent is double this. All right, so we're going to save that for later, but the first steps start out all the same as factoring normal quadratic, where I break down C and try to find the factors that multiply here and add there. I can see it is 7 and 4. I want a negative, so one of them will be negative, and this one tells me that the big one will be negative. And when I check it, yes, that makes -3. That matches up. So I get x minus 7 and x plus 4. Right. Now the problem here is if I FOIL this back, right, when we multiply it back, we should get what we started with. But I can see pretty quickly that if I multiply just x times x, I don't get x to the 10, I get x squared, right? But I want x to the 10. So what do? Well, basically I just have to take half of this exponent or match this one, right? So half of 10, so I just adjust the exponent a little bit into x to the 5th, right? X to the 5th minus 7 and x to the 5th plus 4, right? If I multiplied that out, I would get my x to the 10. And even when I multiplied, a number times the x to the 5th, I get x to the 5th, which match up with my middle term. So this works out. All you have to do is take half of the big exponent, which should also match exactly with the middle exponent.